Good morning. Today, I'll be explaining one of the most common algorithms concept, linear time operation. Before we start, let's briefly talk about what big O nation means. Big O nation is a way to describe how the runtime of an algorithm changes as the input size increases. In other words, it tells as how fast or slow an algorithm performance depending on the amount of data it needs to process. Now, for O notation or linear time, it's mean that the time on algorithm takes grow in directly proportion to the input size. For example, if you have 5 elements in array, the program will take about 5 steps to process them. If I have 100 elements, it takes around 100 steps. So the more data we have, the more time it's need. A simple way to understand this is through looping. When algorithm use a single loop to go through its elements in the list of array. Once that's a linear time operation. In this code, we have an array with 5 elements. The for loop runs once for every element. It prints each number from 1 to 5. If we increase the number of elements to 100, the loop will run 100 times. That's why it's called O notation, because the time it takes grow directly with the size of the input. Linear time algorithms are simple but very important. They're efficient for small to medium-sized dataset, but as the input grow, larger the processing time increase too. Some real-life application of linear time operation: printing all records from a database, scanning through a list of names to find someone, checking every time in an inventory or list. The key takeaway is that linear operations are predictable and easy to analyze. You always know that doubling the input through doubles the processing time. To summarize, annotation or linear time operation means the algorithm performance depends directly on the size of input. I learned through that even though is not the fastest type of algorithm, it's one of the most practical and commonly used in the real-world programming. My main is not understand simple concepts like annotation, help us building a stronger foundation for more complex algorithm later on. Thank you for listening.